We're studying data structures in this is the lab 9, searching and sorting. Now I'll open the questions, we'll go through the questions, we'll see the answers. I'll give you a brief explanation on it. We'll see how to approach the questions, what kind of methods to use to solve the questions as well. Now, searching and sorting are one of the most classic problems in programming. These are the questions. The first question is, you're given an array. Okay, selection sort orders the sort of values will repeatedly putting a particular value into its final position. The search strategy is as follows. You scan it, you get the final smallest value, you switch it with the value in the first position, find the next smallest value, and you keep going through it. This is called a selection sort. Now you'll have to learn all the different types of sorts, merge sort, selection sort, insertion sort. That would help you. Bubble sort as well. Different type of searching algorithms as well. There's linear search, which is actually the worst thing ever, because that's O of n. There's O of n as in it takes linear time. That's not good. You also have binary search, which is O of log n. Now, switch it with the value in the second position, repeat until all the values are in the proper places. If you have this way. Implement a selection sort according to the search strategy shown above. The method signature is given as equivalence. Selection sort smallest. Then selection sort largest. You start from the reverse. Okay. And then do a test program on it. That's it. Okay. That's quite small actually. Okay, we'll go through it. It's actually lab 10, not lab 9. Now the answers. What was the question? Okay, so they want us to do a selection sort, largest. So we have insertion sort as well. Okay. Okay, we copy the path, paste it. Okay, Java C, name type Java, name dot Java. There's an issue. Now it's Java. Mm. Okay. Let's go through the code. We have the array 45, 7, 2, 8, 9, 13. 45, 7, 2, 8, 9, 13, right there. Okay. We have array small, smallest array, largest. This is just going to clone an array and make a copy of it. We don't want to assign the same array. We want to make a copy of the array and assign a new array, same as array to array smallest and array largest. Now we'll use different methods. So the first one will use array selection sort dot select sort smallest, and then we'll do select sort largest. Fine, and then we'll print both the arrays. That's fine. Now to do selection sort, what you do is you find the smallest item and then you put it in the first position, and then you find the next smallest and you put it into the second position. Okay. So for this, you'll have to loop through all the items, number one. Okay, and you'll have to find the minimum. So if you find a smaller value, you'll keep updating it. Okay. So from start till the end, okay, you're doing a nested for loop. So you go start to the end, and then you look at you compare that item with all of the other items. And if you find a item which is smaller than the current item, then you update the item. Once you're done with that, you swap that item. So this is how you do it. You have an array. Let's say you have the values 45, 7, 2, 8, 19, and 3. Okay. We start with the first position, 0, 0, 1, 2, 3, 4, 5, 6, 5, 1, 2, 3, 4, 5. Okay. Now at the 0 position, you will take that as j, or the current value, and then you'll compare from I plus 1. So from 0, 1 till 5. Now j right now is equal to I. So j and I are both at 0. But we'll go through it. And if I find a value smaller than 45, I'll update j. So 7, yes, 7 is smaller. So j is now here. 2 is smaller than 7. It's smaller than the current j, basically. Then you go to this second one. And after this, it won't update. So you go through the whole list with K and you update J every time you find an item from I plus one till the n that is smaller than the J. And if it is smaller, you update it. Now you found the smallest value, which is 2. And now this 2 will be swapped with the first position. In temp, this is the swap mechanism. This is the current. And this thing is find minimum. Find minimum after current. Okay. So in this, you'll find the minimum and then you swap it at the end. So you do this for each of them until the end. And that's about it. That's selection sort. Now, it's not the best way to do it, but yeah, it's a simple way. You go through one by one, and for each item, you check all the next items to find the minimum in them. You check here, that's the criteria, that's the condition for minimum. And if you do find a smaller value, you'll update it here. And you'll repeat it until you keep finding smaller and smaller until you're done. And then at the end, you swap. So that's it. Moving on. Selection sort largest. It's the same thing, except the sign has now flipped. That's about it. And you're going in reverse. That's also flipped. So it's the same thing. Yeah. We swap here, we find everything. M starts from 0. The reason M is 0 because you want the smallest value. You can also keep it as -1. You just have to initialize M as a number, as a very, very small number that can be updated afterwards. And at the end, you swap it. That's the same thing, except you're initializing a J not as I, but as M as 0. That's the only difference. The reason you're initializing M as 0 is because um, you do two things. One, which is you will start from the beginning and go to the end, or you start from the start. Well, you start from I and you go to the end, or you start from 0 and you go to J or I. So I to end or start to I is the same thing. 0 is actually the start. Yeah. And that's what you do. You keep updating it. If you find something smaller, you'll update it. And that's about it. Try these yourself. We'll run the code one more time. And it works. You can see the code. Now, these are really simple. These are very easy. I don't think you need to be concerned about it, but you have to practice a lot. Try to do some past paper questions from the library. Now, the next one, this one. Now we're trying insertion sort. this is how it's done. It's working as well. The same stuff. This is just a tester class. Now this one. How insertion sort is done. I'll show that to you. Insertion sort. What you do is actually that you find the item, you start from the beginning, and you insert the items in the correct position, one after the other. So you start with the first one won't change. Then you start from the second one. The second one is smaller, so it would be placed before 23. Now you go to the third one won't just go to the beginning or the end or whatever. It would go into a specific position. It would go to a position right after you find something which is bigger or which is smaller. So 23 is bigger, so we'll skip this until we find something that is smaller than 10. We find one is smaller than 10, so we insert it. 5, 23 skip, 10 skip, 1 is smaller than 5, insert. 2, 23, it's larger, so skip, 10 skip, 5 skip, 1 is large, is smaller than 2, so we insert. So insert when we find smaller. That's it. Those are the two steps. One is to iterate 0 to n, and then insert when smaller count. Okay. In this case, you'll have n passes. So 5 elements, n passes. Yeah? N passes. We're done. That's insertion sort. Let's look at the code. So the first thing is you take the array and you start from the second value and you go to the end. Now, because the first pass, actually nothing happens in it, right? So we directly start from 1. Now what you do is you initialize this to be I minus 1. That's the value you're trying to insert as. This is the value before 1. So we start with the index 1. Let's just get ourselves an array. 5 to 16, 32, 8. Okay, so you start with 1. 0, 1, 2, 3, 4. Start with 1. Okay. Now 1 is this one. Okay. Now j is I minus 1. Okay. Move elements greater than key to the position ahead. Okay. So j minus 1 is the I minus 1 is the range to insert into. So in each pass, you'll insert that pass minus 1. So over here, if you saw there was the second pass, you can only insert till I minus 1, second minus 1. Third pass, you can insert to the 2 positions. Fourth pass, you can insert to the 3 positions, and fifth pass, you can insert in the 4 positions, right? First pass, nothing really happens. Now, so that's the range to insert into. Now, j is greater than 0, okay? You start from here, and then you keep moving. You keep inserting the item if it's bigger. And then you go back. And at the end, you you take the once you have the range to insert into, you have a while loop from the start, uh, from well n minus one or I minus one till zero. So you're going to be, let's say, doing, if I'm in the third pass, I'll go back like that. Third pass means I'll go to two. So, well, fourth pass actually, this is the fourth position. So the first three items. So I'll do this, and then I'll start from here and I'll keep going back. If I do find that input J, the J in this position is bigger than the key, like 32, then I'll replace it, replace, keep replacing and keep going back. And then when I find that the item is no longer smaller, so there's no more insertion happening, then the while loop will end. At the end, I have to update the key to go into J plus 1. Okay, let's try a dry run for this. 5, 10, 16, 32, 8. I start with key being input I is 1, so key is 10. That's the one I'm trying to insert. Key is what I'm trying to insert. Okay. Then J would be 0. While J is greater than 0, input this, okay? And the input J is greater than key, input J. 5 is not greater than key, which is 10 right now. So there would be no swap. And J would, well, this would not run. Done. Now input J plus 1 is equals to key. So J plus 1 would be basically I, and I would stay where it is. And the reason we're doing J plus 1 is we find out where to insert. This is update. So if you find a smaller value, then you update, basically. So well, for the first one, I would not update. 10 would not go to 5. 10 would stay at your first position, and you're done. You repeat the for loop. I would now be 2. So you can, that would be the key, 16. You try to insert 16, 5, and 10. You really can't. Let's change it. Let's make it 6. Okay, now I should be able to. The key is 6, so I try the first position. Input J is greater than key. 5 is not greater than key. So I would insert the 6 in place of, and right after 5. So here, I will insert the 6 here. Yeah, that's it. So this is basically trying to us trying to find out a value which is not bigger than the key. Basically trying to find if you have a smaller value than the key. So 5 is smaller than key, yes. So you find it and then you insert the item right there. And from there onwards, you would continue. Now, to wrap it up, I think you can try to run the code yourself. Try to practice it. It's quite simple. You just have to do the n passes, find value smaller than the key. If you find it, you insert right after that. Otherwise, if you don't find it, you'll just insert it back into where it was. Yeah, so there's not much to explain here. Try the code. I'll show you a GIF of insertion sort. This is what it would look like. Something. I'll show you another one. This is just a cool picture to make you interested, perhaps, about computer science. Looks very cool, but this is more realistic. Let's see this. 3, it's basically trying to find a position where it's, and you keep moving the others forward. And yep, 3. Now 1, it would go to the start. Keep shifting until you find a value which is smaller. 7, keep moving. I found 6, which is smaller. So this 7 was the key, and I found a value which is smaller. 2 is the key right now. I move everything forward, and I found something smaller, so I'll insert j plus 1 right here. J plus 1, that's where you insert. So you keep shifting the values until you find a value which is not bigger than key. If it is bigger than key, you just keep shifting it forward, forward, forward until you find a value which is not bigger than key, and then you place it right after that, j plus 1. Yeah. Okay, so you can look at this. It's just a basic insertion sort example. I think that's all for today. If you guys have any questions, you can ask me. You can always reach out if you have any doubts with any questions or any project ideas or anything. I can definitely help you with that. So that's all for now. I'll see you in the next lab session.